Okay. Binomial distribution is chance of success m times after n tries. So the probability distribution will be CNM PM IPN minus m. So CNM is a combination of of choosing m from n with without worrying about order. So it can be written as n factorial n minus m factorial m factorial. And this component is pretty much success m times and fail. The other part is failed n minus m times. So calculating the expected value and variance is not trivial on this distribution function. We can, starting from a general case of e to the m to the k power, to write an invariant. So here is just written it out. Pretty much this is m to the kth power, pretty much I to the kth power summing from I equal to 0 to n, which is a maximum. Pretty much you can only succeed n times by trying n times. And this is a distribution function. Since 0 to the kth powers is 0, and pretty much we can just starting, instead of from 0, we can start from 1. And if you have CNI, this is pretty much CNI written it out, and multiply by I, and you can pretty much rewrite it in the same way, but by taking the factorial 1n out, and this pretty much rewrite with n minus 1 and I minus 1, the 1 gonna cancels out, and I minus I factorial and multiply by I. Remember there's an I in the front, so I over I, this cancels out. And this whole thing essentially is C n minus n minus 1, I minus 1. And there's an n, so pretty much you have this equation, I C n I equals n C n minus 1 C minus 1. So you plug it back in here. You got ik minus 1. So there's a k, so it becomes k minus 1. And you got an n. You got an n here. And cn minus 1. So cni become cn minus 1 to cn minus 1 I minus 1. And then the rest stays the same. And you set j equals I minus 1. And in other words, pretty much I equals j plus 1. You substitute everywhere I is with j, you end up getting this expression. Substitute here, 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 here. For the counting, it's a bit tricky, at least for me. You pretty much going from, since j is starting from I equal to 0, it just become j plus 1 equal to, starting from I equals to 1, so it's pretty much is equivalent to j plus 1 equals 1, which is starting from j equal to 0. And and it ends, the previous summations ends at n, but this time is gonna be one less than the previous one, which means it's gonna be n minus 1 and at n minus 1. So here is a new equation we have, and we take the n and one of the p out here, copy everything here, and the j from j pj plus 1 become pj. And this equation, if you look at it, is pretty much is successing j plus 1 to the k. So this has become expectation value of j plus 1 to the k minus 1 power of a distribution of this distribution. Pretty much is success j times with n minus 1 experiment. So this can be this pretty much this meaning like E prime, meaning the event of y plus 1 success out of n minus 1 trials. So that's what we have. Out of this derivation, we have this. Expectation value of m to the kth power of m success out of n trials equals np. N is the total trial, n trials. P is probability of success of one trial, success rate. And E prime is the event, is the probability is for the expectation value of distribution value that is having n minus 1 trial as success y plus 1 times, and where this is to the a minus 1 power. Let's plug it in to k equal to 1. I just, for the convenience, where we're gonna have it here. So k equals to 1, plug it back in, is e to the m, em equals np e prime y plus 1, k is 1, so it's y plus 1 to 0's power. Since expectation value of any constant, then you will have this. Since expectation value of any constant is its own constant, so expectation value of 1 is always 1, because you just sum over 1 of all the probability, and it's equals to the sum of all probability. Sorry, alpha, let's assume the general case. Then it's alpha taken out because it's a constant, then it become alpha. So it's always, so this become 1, then we have expectation value, hooray, np. And let's set k equals to 2, plug in the same formula that we have, m squared np e prime y plus 1, because it's k minus 1, right? So it's gonna become to the first power. Since we know that from the previous derivation e to the m equals np, then we can calculate the e prime y plus 1. This can be based on the principle we can divide into 2, like e prime y plus e prime 1. This again is 1, and this is trying n minus 1 time, so it's n minus 1p plus 1. So we plug this back in here. We'll have np from here, equals n minus 1p, which is this, plus 1. And we know that variant of m is equals the expectation value of x squared minus expectation squared. So when we plug in, we have em squared, which is this, and expectation value here, which is this, and you put everything back in, end up getting this expression after some algebra. And there we go, expectation value and variant of binomial. Intuitively speaking, it kind of makes sense. Of at least expectation value, you can imagine you just try n times with probability of p success, and that's expectation value of how many success you will have.